Hello guys, this is 不专业研究所. Well, in my daily study, I try to find some information about adsorption. It is mostly some papers from which it is difficult to find the needed information. So I want to make a channel to give a brief overview of the knowledge related to this field. And I hope you can have some understanding of the basic concepts of adsorption through my videos. In my video series, I will focus on the following topics: the gas adsorption basis, adsorption mechanisms. In this part, I will talk about some things about adsorption, phase, and fighting behavior of fluids on planar surface and in nanoporous materials. The third part is the characterization of nanoporous materials and contains about the surface area assessment, for size, for volume, and for network analysis, and also the recent advances. In the first part is the separation by adsorption. It's talk about some methods commonly used in industry like pressure swing adsorption and temperature swing adsorption. At first, I would like to talk about two approximate concepts: absorption and adsorption. In the picture on the left, we can see an absorption process in gas-liquid phase absorption. For example, the molecules from the gas phase cross the junction between the two phases and enter into the liquid phase. We can call this process absorption. The absorption process is similar to the adsorption, but the difference is that during the adsorption, the particles in the gas or liquid phase will only stay on the surface of the second phase and will not enter into the second phase, as shown in the diagram on the right. The particles in the gas phase we call adsorptive. The solid bar is adsorbents, and the particles absorbed on the surface of the solids is the adsorbents. The gas adsorption will be explained in my video. First of all, what is adsorption? Also, adsorption is divided into two types: physical adsorption as well as the chemisorption. When the interaction between a surface and the adsorbent is relatively weak, then the physical adsorption takes place. And about chemisorption, the surface atoms often possess the electrons or electron pairs which are available for the chemical bond formation. This two process is enrichment of the adsorptive at external and accessible internal surface of a solid. The physical adsorption is driven by van der Waals force, while the chemisorption is driven by chemical bonding. So the energy of the physical adsorption is much smaller than the chemisorption. In addition, physical adsorption will occur multi-layer adsorption, while the chemisorption can only form single-layer adsorption because of bonding. But chemical bonding is higher energy and not easy to break, and it will be slow or will not dissolve during the desorption. While physical adsorption can be dissolved by lower the pressure or lower the temperature. The van der Waals force have three components, which are the Keeson force, Dubai-Hooker, and London force. They differ due to the different interaction of the molecules. For example, the dipole and dipole. The Dubai-Hooker is between the dipole and induced dipole. Among them, the dispersion is the most important because the dispersion force are present in almost all the process. In the process of the two particles approaching each other, an interaction occurs, which we call the Lennard-Jones potential, and it consists of repulsive and attractive force. As shown in the following equation, the distance between the two particles changes. The repulsive and attractive force will develop into different degrees of variation. And finally, we can get a curve in the figure where we can see the variation of the interaction at different distance. However, in the adsorption process, the force on the gas molecules are generated by the adsorbents, but there are a large number of molecules on the surface, and all the forces add up to finally get the equation in the figure, will shift from the 12.6 to the 9.3. So these are some basic concepts about adsorption. Thank you for your attention.